Good day, students, and welcome to a special edition of a math video. I don't know what else to call this. So in this video, I'm going to be showing you kind of a quick review and understanding about how we distribute and factor expressions. If you want a more in-depth look about how we do each of these, I have two separate videos, one on the distributive property, one on factoring expressions, that are linked in the description bar below that you're more than welcome to use to kind of help you understand these things even further. So the first thing we're going to do is we're going to talk about the distributive property. So when we're given an expression, kind of like what you see here in these two examples, when we use the distributive property, we're going to be using this word distribute to mean to give through multiplication. I abbreviated multiplication just to these letters here. So what that means is if I have the expression 3 times the group x minus 7, this is just saying x minus 7 plus x minus 7 plus x minus 7. It's that same group added over and over and over 3 times, or 3 times that group. That's how multiplication works. So another way that I could simplify this expression, instead of going through and adding all the x's and adding all the 7's, is I could just multiply 3 times each term in the group to simplify. So if I multiply 3 times x, well, those are two different terms. So a number times a variable is just going to be 3x. And then if I do 3 times 7, that is going to be 21. And I'm going to keep the subtraction sign in between. So this expression 3x minus 21 is the same as 3 times this group x minus 7. Let me show you a different example. So here we have one. And you know what? Let me do this. I'm going to cover up the factoring side so we're not distracted by those equations. Here we have the problem -4 times the group x plus 6. So if I use the distributive property to simplify this expression, I'm going to distribute that -4 to each term in the group. So -4 times x is just going to be -4x, because we don't know what x is. And then if I do -4 times 6, that is going to be -24. But when we add a negative, that's the same as just subtracting that number. So the way to simplify this expression fully is, instead of putting -4x plus -24, I'm just going to put -4x minus 24, because when we add a negative, it's the same thing as just subtracting the positive version of that number. Let's look at one more example about how to use the distributive property. In this case, we have the problem 2 minus 3x minus 7, or 2 times the group minus 3x minus 7. So if I use the distributive property, to distribute this 2 to -3x, while they are not like terms, we can multiply the coefficients here. We can multiply 2 and -3 to make a new term. So 2 times -3 would be -6, and then we have to keep x attached. And then if we do 2 times 7, that is going to be 14. And we're going to keep the subtraction sign in between. So you can think about this problem when you distribute the 2 is 2 times -7. Or you can think about it as 2 times 7 and you keep the subtraction sign. If you think about this as a -7, remember when we add a negative, like what we did up here, it's the same as subtracting. So either way, this simplifies to -14. So this is how we use the distributive property. However, sometimes when we're solving equations, or when you get a little bit further into your algebra career, we need to take an expression and we need to factor it. We need to figure out how can we rewrite it as kind of what it looked like before we use the distributive property. So factoring undoes the distributive property through division. So let's look at some examples. So essentially what we're doing is we're going to be trying to figure out what is the greatest common factor amongst the terms in our expression. And we're going to rewrite it in the format of what it looks like over here before we use the distributive property. So if I look at my two terms in this first example, we have 12x minus 24a. They are not like terms because they do not have the same variable. So I cannot pull out an x or an a from this expression because they do not share x and a. But 12 and 24 do share similar factors. There are numbers that we can divide 12 and 24 both by. So that is what we are going to pull out of this expression. So essentially what I'm going to do is think about what is the greatest common factor between 12 and 24. And that is going to be 12. 12 is the biggest number that I can divide 12 by and 24 by without there being any remainders, decimals, and so forth. So the way I'm going to format this is I'm going to format this as 12 times, and what's going to go on the inside of my group is just, well, whatever times 12 made these two terms. So I think about what times 12 makes 12x. That's just going to be x, right? Because 12 times x is 12x. And then if I think about what times 12 makes 24a, well, a still needs to remain. And what times 12 makes 24? That's going to be 2. And I'm just going to keep the subtraction sign that's already happening in the expression here. So you'll notice that when I factor this expression, I have 12 times the group x minus 2a. And if I go and use the distributive property, that's a way that I can check my answer. If I do 12 times x and 12 times 2a, I should end up with this expression, which is what happens. Let's look at another example. This one has 3 terms. However, 2 of them are like terms. So we can either find the greatest common factor between the 3 terms, or we can combine our like terms and then find the greatest common factor. Either way, we end up with the same answer. So I'm just going to say, let's combine our like terms first. So 51x plus 3x can simplify to 54x plus 3. So now if I look at what's the greatest common factor, they don't share an x, so I'm not going to pull out x from this expression. If I think about what's the greatest common factor between 54 and 3, that's going to be 3, right? I can divide 3 by 3, and 54 is also divisible by 3 as well. So if I put it in its pre-distributive property format, it's going to be 3 times the group, and then whatever's left. So 3, what times 3 makes 54x? Well, really, I have to figure out what times 3 makes 54, or 54 divided by 3, which is 18. And then I'm going to leave x there. And then what times 3 makes 3? That's just going to be 1. And I'm going to keep my addition sign here. And if I go back and distribute, 3 times 18 is 54x. 3 times 1 is going to be 3. So it simplifies to this expression, 54x plus 3. All right, let's look at one more example. We have 10 plus negative 2x. So there's 2 different ways that I could factor it. I could think about pulling out a negative number, because even though one of these is negative and one of these is positive, we could divide 10 by negative 2. That's possible. We're just going to end up with a negative answer. Or I can also think about this as when we add a negative, it's like the same as subtracting. So this is the same thing as 10 minus 2x. And here now I don't have to even really worry about negatives. So I'm just going to kind of solve it this way. I could have done it the other way where I pull out a negative number. It'll still end up simplifying to the same thing we're about to get. But remembering that when we add a negative, it's like subtracting, kind of makes our lives easier. So, okay, if I think about the greatest common factor between these 2 terms, they do not share an x. So the only thing I can pull out is the greatest common factor between 10 and 2. Which is going to be 2. So I can divide 10 and 2 both by 2, and I will be left with 2 times 5 is what makes 10. So 5 is going to go here. And 2 times 1 makes 2. But 1x is the same as x. So what times 2 makes 2x? That's just going to be x. And then I'm going to keep the subtraction sign here. I could put a 1 right here, because technically 2 times 1x would be 2x. But remember, 1x is the same thing as just x by itself. And again, if I distributed, 2 times 5 is 10. 2 times x would be 2x. We keep the subtraction sign, so it simplifies to the same expression. So understanding the difference between these 2 is key. I encourage you, if you're struggling, to go watch the distributing and factoring videos that are separate, that have a more in-depth explanation. Here are your practice questions to practice distributing and factoring. You have 2 of each kind. So your practice questions today, you're going to distribute 3 times the group x minus 4. You're also going to distribute the group 17 minus, this is a 6x plus 5. And then you're also going to factor, excuse me, you need to see both of these. You need to factor 12g plus 16c and 13x plus 39. When you are done, you can go check your answers in the table of contents. And I hope y'all have an awesome day.